Welcome back for Chapter 5, Section 6, using the distributive property. You can see I've got Sharu here keeping me company for a minute. He is quite a cuddling nuisance and demands a lot of attention. Content objective says students will use the distributive property to expand and factor expressions, and the suggested pacing, wow, 135 minutes. This one might just take us a little while, but you know, the textbook hasn't exactly been real accurate. It only has 15 slides. I mean, how bad can it really be? Yeah, right. Suppose that you and two of your friends are going to a concert. As you approach the ticket window, you see that the tickets are $27.09 each. Using mental math, how can you find the total cost of 3 tickets at $27.09 each? These are some of the things we're going to be talking about while we're doing this lesson. The inquiry question says, how can you use algebra tiles to model the distributive property? Well, let's find out. It says, use the tiles to model 2 times the sum of 2 and 3 in the workspace. Record the problem and your solution. And it says, what steps did you take to model the expression? And what other value expressions could have the same value and the same result? Well, let's take a look here. Each tile represents 1. So, alright, your red ass and little gums keep rubbing on my chin. You have 2 plus 1, 2, 3. But you have that 2 times. So you got another set of 1, 2, and 1, 2, 3. So right here you see 2 times the sum of 2 and 3. Other ways you could do it, well, you could take and stick all those together, and when you do that, you could have 2 times 5, or you could pull them apart and you could take and say 2 times 2 first became 4, 2 times 3 second became 6, and then added those together. Lots of different ways you can use them, and we're going to be using some of these ways in solving with the distributive property. But what if our problem said 2 times x plus 1? Well, we don't really know what x is, but we can still model it. So I can say I've got 1x plus 1, I've got 2x's plus 1, and using the distributive property, you would say 2 times x gives you 2x, and 2 times 1 gives you 2. That's some examples of how we're going to do it. We're going to put some numbers to it in just a minute, and it's probably going to make more sense to you when we do that. What if we had 2 times 2x plus 1? Well, for that one, I've got 2x's and 1 here. I get 2x's and 1 here. And once again, I can do 2 times 2x's plus 1, or I can do 2 times 2x, which gives you 4x's, 2 times 1, which gives you 2, and either way, it gives you the same exact values when you're all said and done. Now, we're not going to make the conjecture they want to do here because I think there's better things we can do with their times, but I'll go ahead and show you what their sample answer is. Their sample answer said, I can multiply each term in the parentheses by the factor outside the parentheses and then write the products as a sum. Now, that's probably confusing for some of y'all because for some reason you just don't like it when words appear in your math, but we're going to work on improving that as the year goes on. Here they've given us another problem where they have 3 times the sum of x and 1, and they also want us to represent it as 3 times x plus 3. So first off, I have 3 times the sum of x plus 1, so I've got 3 groups of x and 3 1s. So right here I can show that I have 3 times x plus 1. I could also do 3 times x, 1, 2, 3, plus 3 times 1, 1, 2, 3, where we find this part first and this part second, and then we add them together. Either way, it's going to give us the same exact answer in the end. And we could keep going with this problem, but I think we've pretty well beat this horse enough. So let's move on and see what else the textbook has in store for us. And with that, it's time to learn the distributive property. You can see they've defined it. This will be one of the terms you're going to have on your vocab quiz. The distributive property states that to multiply the sum of a number, you have to multiply each term inside the parentheses by the number outside the parentheses. That sounds a little fancy with words and all, but when you see it with numbers, it really isn't that hard to understand. So we're going to flip it over. Once again, there's the same exact words they just gave us. There's no reason to mess that up. But as we scroll down and these load, we're going to see it represented with variables and represented with numbers, I suspect. So here it says 2 times the sum of 5 and 6 is the same thing as 2 times 5 plus 2 times 6. Think about it. 5 plus 6 is 11. 2 times 11 is 22. 2 times 5 is 10. 2 times 6 is 12. 10 plus 12 is 22. It gives you the same exact answer whether you use PEMDAS on the left or you use the distributive property on the right. And this is an example of the distributive property where we distributed the 2 through the grouping symbol, multiplying it by everything that was inside the grouping symbol. Doing it with variables, A times the sum of B and C is the same thing as A times B plus A times C. And now it's time to watch a video from our sponsors.
The distributive property lets you multiply each addend of a quantity written as a sum by the number outside the parentheses. To apply the distributive property to the expression A times the quantity B plus C, multiply each term inside the parentheses by A. A times B plus A times C. The expression can be written as AB plus AC. Consider another example. Apply the distributive property to the expression 2 times the quantity 3 plus 5. Multiply each term inside the parentheses by 2. 2 times 3 plus 2 times 5. This can be written as 6 plus 10, or 16. Finally, consider the expression 3 times the quantity x plus 4. To apply the distributive property, multiply each term inside the parentheses by 3. 3 times x plus 3 times 4. The expression can be written as 3x plus 12.
That's actually one of the better videos they've done to explain a concept, so that will hopefully help you understand everything we're fixing to do in here. Our talk about it says when there are only numbers in an expression, such as 3, 4, and 9, 3 times the sum of 4 and 9, is the distributive property the only way to evaluate the expression? The answer is no. You could use PEMDAS. You could use Please Excuse My Dear Aunt Sally, also known as the order of operations, solving what's in the parentheses first and then multiplying that by 3. Either way, you get the same exact answer. So let's look at example 1 for using the distributive property, and we'll use it to expand 2 times the sum of x and 3. First off, it asks us, what does the word distribute mean? Well, you have distributors who distribute goods that people are buying, so they buy a lot of things in wholesale and they're distributed out through lots of different places. And that's kind of what we're doing here. We're taking that 2 and we're distributing it out through everything inside the parentheses. So to do this, the first thing you're going to do is write your problem. If you do not start off by writing your problem, you will have done it just for fun. From there, I would prefer to see it directly underneath. They went one slide over. It's okay. They said 2 times x, 2x, 2 times 3, 2 times 3 right here. And from there, 2 times 3 is 6. 2 times x is 2x. So you could go back and write it as 2x plus 6. Check your answer, and the answer checks. It really is that simple to do these problems. And now it's going to be your turn to solve one of the problems using the distributive property on your own. As soon as it pops up here. Anytime now would be nice. Alright, here it comes. There we go. 5 times the sum of 9 and x. You go ahead and do that on your own in this problem. So let's take a look at what we would do. We would start off by, well, I'm going to go ahead and take a picture because they're wanting us to go straight to the answer, and guys, I'm just not ready for an answer. I want to be able to have some supporting work, because supporting work, you know, that just really makes the world go round. So we're going to take our problem, 5 times the sum of 9 and x. My next line, of course, I'm going to have an equal sign in here, and I'm going to go 5 times 9 plus 5 times x. 5 times 9, that's going to end up being 45 plus 5 times x, that's going to be 5x. And that would end up being the final answer that you would put in here, 45 plus 5x. I'm not real happy with the textbook for writing it that way, because the standard form of writing a mathematical expression is a variable goes first, so you should technically write it as 5x plus 45, but we're not going to hammer them too much on that concept. Now they want us to use a distributive property to find 8 times 3 1/2. Now, when I first looked at that, I thought, wait, what? Why? But then I realized exactly what they want to do. They said you could rewrite 3 1/2 as the sum of 2 terms, and those terms are going to be 3 and 1/2. So it's going to come up here in just a second. You got their problem where you write the original expression. From there, you can see they broke it down 8 times the sum of 3 1/2. Next thing they're going to do is use the distributive property. 8 times 3 is right here. 8 times 1/2 is right here. 8 times 3 is, of course, 24. And 8 times 1/2, well, you could also say that as 1/2 of 8 is 4. And finally, 24 plus 4 is 28, which you could write in that box if you really wanted to. But that's a real good example of how you could use a distributive property on solving a problem like this one. Our talk about it says, could you use a distributive property to multiply a 1-digit and a 2-digit number, just such as 9 times 37? And the answer is absolutely. You guys watch me do this all the time in my head. So 9 times 37 is going to be, there we go, 9 times 37, whoops, that's not a 7, that's a 0, is the same thing as saying 9 times the sum of 30 and 7. And I would say from there, and my mouse thing just quit working on me, there it goes, that's the same thing as saying 9 times 30 plus 9 times 7. And from there, 9 times 30, that's 270, plus 9 times 7, that's going to be 63. And you add those two numbers together, and that's going to be 333. I do that in my head all the time with you guys in class. That's how I work those problems so quickly and easy without a piece of paper. Now, once again, it's going to be your turn to do a problem on your own. Go ahead and pause the video and do this, and then we're going to come back and watch me do it as well. This is going to be the last problem we do in part 1 of this video. So did you check it? Did you get the right answer? I hope so. We could rewrite this as saying 9 times in parentheses the sum of 4 and 1/3. That's very similar to what we did on that 2 problems ago. From there, we can take and say, use your distributive property, 9 times 4 plus 9 times 1/3, which that would end up being put over 1. 9 times 4, that's easy, it's 36, plus 9 times 1/3, well, let's simplify. 3 goes into 3 once, 3 goes into 9 3 times, and when you do all that multiplication, simplifying after that, you're going to find that you would end up getting 3 over 1, also known as 3, leading to the final answer of 39. We're going to jump back over here to our problem, type in 39 and check, and the answer checks. Easy math. Distributive property, guys, it's a really big deal in math. It'll really help you to do math both on paper and in that scary little dark head of yours. Now, as I said, that's going to be the last problem we do for video part 1. Come back in just a little bit and watch part 2 as we continue to explore the distributive property, only now we're going to be using the greatest common factor when we do it.